Hey guys, it's your favorite Algebra 1 teacher here. Looking at our homework, simplify the following expression. Write it in two ways, one with the use of negative exponents and the one with the use of a fraction that doesn't have negative exponents. So this applies our exponent properties, and when they are stacked, we want to subtract our exponents. 5 minus 9 is going to give me x to the negative fourth power. So there we have a negative exponent, so there's one of the answers. And the other answer is to turn it into a fraction, so it'd be 1 over x to the fourth power. There's one answer, there is the other answer. Second question, simplify the following expression. So you want to bring that 2 in, so that would be 3 to the second power. And x, we want to multiply those exponents to give you 6. Then down here at the bottom, you want to multiply 6 times 2, which gives you 12. And then you also want to multiply x times x. X to the first power times x to the first power. Remember, we're adding those exponents, so that gives you x to the second power. Clean this up a little bit. 3 to the second power is 3 times 3, which is 9x to the sixth, 12x to the second power. Always reduce your fractions. Don't subtract these. These are not exponents, but reduce your fractions. You're going to subtract your exponents. Looks like 3 will go into 9 3 times. 3 will go into 12 4 times. So 9 twelfths reduces down to 3/4. However, you do subtract your exponent. 6 minus 2 gives you x to the fourth. Next question, an object's speed can be modeled with the equation s equals 24 times 1.06 to the t power, where s represents its speed in miles per hour and t represents the time that has passed in seconds. Give an interpretation of the parameters 24 and 1.06 of the equation. All right. So 24 is in our starting location. So we are initially moving 24 miles per hour. And since this number right here, 1.06, is greater than 1, that means we are going to have an increase, and we are increasing by 6% per second. All right. And t, of course, represents our time. Down here for number 14, an exponential function f is shown in the table. Determine the equation. All right. So there's my starting point. Whenever x is 0, 13 is where I'm starting off. So that 13 is going to be my a. My b is my second y divided by my first y. So I've got 117 divided by 39, or I can do 39 divided by 13, or I can even do 351 divided by 117. Looks like 39 divided by 13 would be the easiest. I'm thinking that will be 3. 13 will go into 39 3 times. So my b would be 3. That's my a. So y equals 13 times 3 to the x power. And I think we should have used f of x. So f of x equals 13 times 3 to the x power. Okay, let's keep going here. Max deposits money into a savings account that earns 3.5% interest applied annually. If Max initially deposits $450 into the account, how much money does the account hold after 5 years? If Max does not deposit or withdraw any additional money, show how you arrived at your answer. All right, so we're starting the account at $450. we have a growth factor. We're going to grow because it's in a savings account. And we need to turn 3.25 into a decimal. So that'd be 0.035. And since we're growing, we're going to add a 1 onto that. So it'll be 1.035. And we're going to raise it to 5 years. And I'm going to plug that in my calculator. Oh, batteries are low, but we're going to keep using them. 450 times 1.035 raised to the 5th power. And it's going to be about $534.46. $534.46 that Max should have in his savings account. So this is money, so we got to round to the 100th place value. 16. Determine the equation of the exponential function shown in the graph. Explain how you arrived at your answer. All right, so I can tell that this is a decrease. It's going down. So that means the number inside the parentheses has got to be less than 1 but greater than 0. All right, I'm going to pick some values here. Most importantly, I want to figure out where it's starting, where it's crossing my y-axis. Where it crosses my y-axis is going to be my A. So if I say that these goes by 1, and I don't know anything else, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It looks like it crosses right there. So that's going to be 0 and 10. That is going to be my A. Remember, your equation is y equals A times B to the x power. And we need to figure out what we are decreasing by. So I'm going to find another point. Try to look for an easy point that passes through here. We could use this one right here. I'd like to go further down on the graph, and we could use this one right here. Maybe that would be 1, 2, 3, 4. Maybe that would be 4 and 0.5. And remember, our B is your second y divided by your first y. So if this is my first x and this is my first y and this is my second x and this is my second y, remember it's got to be decay, so I may have to switch these around. So I've got 0.5 divided by 10. Well, that's 1/2 divided by 10, and 1/2 divided by 10 is going to give me about 5/100ths. And I think I want to use this number right here just to verify. So this right here would be 1 and 1, 2, 3, 4, 5. So 1 and 5. I like these 2 points right here because they look more precise. So if I say this is my second y, then I would do 5/10. And 5/10 obviously reduces down to 1/2. I like that one better, so I'm going to say y equals, my starting point is 10 times 1/2 to the x power. So that gives us a better estimation of what the graph is. So I wouldn't use that point at all. Down here for number 17, write an equation of the linear function that passes through these 2 points and write the equation of the exponential function that also goes through these 2 points. So I need x1, y1, and x2, y2, and use the slope formula, y2 minus y1 over x2 minus x1. So that gives me 24 minus 8. And 1 minus 0, which is 1. 24 take away from 8 would be 16. So 16 over 1, and of course, is 16. So that means my slope is 16. My starting point is going to be right here where x is 0. That's my starting point. That's my b in linear equations. That's my y-intercept. Exponential, the a is the same as your y-intercept, which is 8. And then my b, remember, is your second y divided by your first y. So it'll be 24 divided by 8. 24 divided by 8 is 3. 24 divided by 8 is 3. So that gives us the growth factor. How much greater is the exponential function value of x equals 5 than the linear function's value? Show how you arrived at your answer. So we're going to plug 5 in here. So y equals 16 times 5 plus 8. 16 times 5 plus 8 gives us 88. Calculator's shutting off because I need batteries. And for my exponential, I'm going to do y equals 8 times 3 to the 5th power. Let's see if it'll turn back on. And I've got 8 times 3 to the 5th power. So that's going to give me 1,944. Well, how much greater is that? Well, minus 88, and we get 1,856 greater. Remember, this is growing exponentially. Number 18. A geometric sequence is defined by the following rule. Find the fourth term of the sequence. Show how you arrived at your answer.